All right, welcome back, everybody. Oh, there we go. Someone showed up. Excellent. Oh, I got light in my face. Let's do some review of solving logarithmic and exponential equations. Let's start with one that's in light, a little bit light. What if we had something like this? Go ahead and give it a try, see what you come up with. One more minute, we'll do it together. All right, what can we do? Okay, like take ln on both sides. Let's see what happens. So what do you think happens here?
That's where I got stuck. I was like, well, I'm like, log 6.
Right, so that should be something like, I don't know what happens, maybe I shouldn't go this route.
Yeah.
It's always worth trying stuff, so that's not gonna work. So one thing we can do is we can use the rules that we have and rewrite this This is log base b of y equals x. And this becomes, wait, I got it backwards. B of x equals y. So this is b to the y equals x. B here was 6. So that's a 6. The y is the opposite side, so that's a 2. And x is what's inside the logarithm. 2x plus 4. Now, that's the other way we can do it. The other way that you might like better, once you get used to doing it, is whatever base is here, treat this whole thing as an exponent for that base. And do it on both sides. Because this part right here cancels out, cancels each other. And this kind of just comes down and we get 2x plus 4 equals 6 squared. And you can see we have the same thing either way. I like this way better myself because I see it's there. I just gotta remember to raise it to the power and cancel it. Here, I gotta like stop and draw a picture of the default setting and start matching shit up. Because there's 3 parts that I gotta match up, and here it's just remembering a couple rules, but either method will work there. At this point, it's straightforward. 6 squared is 36. And now we're just solving a linear equation. You can always check it. Does log 6 of 2 times 16 plus 4 equal 2? This will get us log 6, 36 equals 2. And if your calculator doesn't have something like that, when you don't remember, you don't want to deal with this, you can always do this as log 36 over log 6. Or ln here. That's doing the change of base, but it should work, yes. Any questions?
How would we write the little 6 by 1? Or
I'll have to see your calculator. Let's see what you got. Yours doesn't do it.
so I'd have to like
You would have to go with the change of base. Well, some of them don't have it because the change of base formula is straightforward. Once you remember how to do it. Any questions online? All right, let's pick it up a notch. Let's go with something like ln of 3 minus x plus ln of 5 minus x equals ln of 50 minus 6x. Everyone get the start done? All right, so how do we start this shindig off?
Like, yeah, combine 3 minus X. 5 minutes. But.
We will, but how do we combine them? You're correct. These two will go together to make one.
Distribute.
We will distribute them, but first let's just put them together as multiplication. The next step is distributing them. But yeah. Now you can either distribute first or raise both. There's a couple ways for it. We can distribute first, or we can deal with the ln first. We're going to go with distribute first because that's what you were saying. So if we distribute, we have 15 minus 8x plus x squared. And I realize that's not in proper order, but that's just the way it is right now, and we'll clean it up in a second. Now, a couple ways forward. You can recognize that if this is natural log and this is natural log and that's an equal sign, the only way these two things are equal and they're both in natural logs is these two have to be equal. The other option is raise both. Remember, natural log is the same thing as log base e. And we were saying whenever you have a log and a base, just raise both sides of that power. And when you do that, the e and the ln cancel out. And we're left with this, which I'll put in correct order now. And I'll put this in correct order. That's the same thing as recognizing that the insides match, so they got to match. The e thing always works though. You don't always have an ln on both sides. Well, now we just got to solve for x, which means we got to get everything to the same side, right? Get x squared minus 2x minus 35 equals 0. That's x minus 7 and x plus 5. So x equals 7 or x equals negative 5. Then we have to check them. Anytime you do anything crazy like put them together like that, you got to check them. So let's check them. I check in x equals 7 in the first equation. I have ln of 3 minus 7 plus ln of 5 minus 7 equals ln of 50 minus 6 times 7. This is going to give me ln of negative 4. Ln of 8. Fortunately, we have a problem now. You can't have negative values on the inside of natural log. The graph of natural log goes like this. It never, it's x is greater than 0. It's a requirement. Which means x equals 7 does not work. Yep. Now we can try x equals 5 or negative 5. I've got ln of 3 minus negative 5 plus ln of 5 minus negative 5. Does that equal ln of 50 minus 6 times negative 5? This is ln of 8 plus ln of 10 equals ln of 80. Those work, because even when we put these together, we get ln of 80, and I don't even know what that value is in the calculator, but they match already. And they don't violate the rules, so. Only x equals -5 is a valid combination. Questions?
So as long as there's no negative in the
Or 0,
it's the correct answer.
pretty much. Oh, well, I want to say yes, but that's under the assumption you did everything else right. If you make a mistake up here, you'll get wrong answers that will give you positive numbers in here, but actually don't produce, when you solve it, don't work, because if you make a mistake up here, you get the, you know how it works. But assuming everything along the top was correct, yes. It's worth getting to this point right here, because then you can see they're equal. You can even do that in a calculator without having to remember that step. ln 8 plus ln 10. Find out what that is, and then do ln 80 in the calculator and make sure they're the same. All right. What else we got here? That's a fun one. I think the first step's not too bad. But I don't know, I think I'm going to do it that way. I don't like the minus signs, to be honest. I really don't like that and that. Because it means division, and if I divide, I'm going to have a fraction in here. If I can't even do anything with this as it is, because it is. So what I think is the best option you have is to add the ln of x minus 2 to both sides. And then add the ln of 4 to both sides. And if you do that, you have ln of 4x minus 2 plus ln of x minus 2 equals ln of 4. Now we can put them together. We don't have any division. Same thing we did last time. We raise both sides to the power of e. The right side becomes 4. This side, I'm going to factor it as I do it. Not factor, but multiply it out. I've got 4x squared minus 2x minus 8x plus 4. So I get 4x squared minus 10x. And if I subtract 4 from both sides, those go away and that equals 0. What do I do now? I ask because this throws off a lot of students. We don't have 3 terms, so I can't do like trinomial factoring anymore. I can still factor them. They're both divisible by 2, so I could bring out a 2. And they're both divisible by x. If I do that, I'm left with 2x and -5. This gets me 2x equals 0. Or 2x minus 5 equals 0. So x equals 0 or 2.5. Again, we did some stuff that changed it around. So we should go back and check. If I do 0, a couple of those things are negative. I get ln a -2 on a couple of them. Which means as soon as I do the first one and I see I get a 0, I don't even need to write out the rest. No. X equals, that's 5/2 or 2.5. If I stick that in, I got ln 4 times 5/2 is 10. So 10 minus 2 minus ln of 4. Does that equal negative ln of 2.5 minus 2? So ln of 8 minus ln of 4 equal negative ln of 0.5. Or better yet, 1/2. These turning into division. This is ln of 8/4. This, without even using a calculator, remember that numbers in front we can make exponents. This is really a -1 in front. So this, I could rewrite this as ln to the 1/2 to the -1 like that. Which means this side is, flip the fraction over, is 2. And this side, 8 divided by 4 is 2. And you get the same answer. Yeah.
So, are you at the base of E and then make the element an exponent, right? Does that like basically transfer?
Yes, because the ln is the same thing as log base e. So doing e to the ln is doing e to the log base e. And whenever you have the base to the log exponent, the exponent is a log with the same base. That just kind of, whatever is here, this whole thing just equals that value. We did that on the first one with base 6. Here it's base e. There you go, got another one. let's say we've got log base 2 of log base 2 of x equals 1. Well, tricky. We got a double log and they're put together, one's inside the other. When you've got one inside the other, kind of got to deal with them in order. You can't deal with them at the same time. So to get rid of this log, I'm going to raise it to base 2 on both sides. That'll deal with that. And I'm left with log base 2x equals 2 to the first power, or just 2. Then we do it again. X equals 2 squared is 4. I can see by plugging it in, 4 gives me a positive number on the inside. It shouldn't be a problem. What is this madness? What is this madness? Oh my goodness, I like this one. Maybe I should put that in parentheses. It doesn't have it in parentheses, but it's implied. All right, so this is a little tricky. I got different things on the inside. And I got a square outside the logarithm. That's the trickiest part right here. This parentheses squared thing means I can't just do the normal. This isn't like the pull down the 2 in front thing, because the exponent rule only applies when it's on the inside, like here. So I can't do that. But I can do it over here. I can rewrite this one as 2 log x. And I got log x squared over here, like that. One thing we could do, and we're going to definitely need to check some work later on to make sure it works. But I've got log x on both sides. If I say u equals log x, this becomes 2u equals u squared. And I can solve this. I get 0 equals u squared minus 2u, which is u times u minus 2. I'm going to get u equals 0 or u equals 2. Then I gotta go back up here and do that. I've got log x equals 0. Or log x equals 2. What do I do there? Question. What kind of base do I have when it just says log? Okay. And pencil that in because it kind of tells me, inspires me what to do. If I want to get rid of the log base 10, I can raise both sides, treat both sides as an exponent for 10. This whole thing becomes x equals 10 to the 0, or x equals 10 squared. X equals 1 or x equals 100. Does it work on both? If I do x equals 1, I get log 1 equals log 1 squared. Log of 1 is 0. So 0 equals 0. That does work. The other one is log of 100 squared. Does that equal log of 100 squared? It might. This is 2 times log 100. And log base 10 of 100 should be 2. So this should be 2 times 2 on the right side or left side. It's 4 on the left side. Log base 100 here is 2 and it's getting squared. And that's also 4. This is probably something I would throw in a calculator. Because knowing that log base 10 of 100 equals 2 is, I'm doing the whole log base 10 of 100 equals what? 10 to the question mark equals 100. So question mark equals 2. I'm going through some steps kind of quickly there. But calculator, you can do it right away. So both of them work. That's pretty nice. Any questions? It's only a few minutes. I'll read. Let's stop for here. That's plenty of practice.